So today I will give a brief update on the progress we made since last year with respect to modernizing our user interface. And we believe that these changes should significantly improve the overall user experience. So before we dive into that, let's take a brief moment and reflect on the UI design of the past 18 years. Many of the core decisions made back then proved to be excellent choices and withstood the test of time very well. And we are building on these core decisions of the early days and streamlining them with the modernization process we started a few years ago. Two major changes of the UI, the most visible ones, are that we replaced the tool panel on the left-hand side with the activity bar as shown here. And this activity bar allows quick access to workflows and tools and pages and all the other resources. This also enabled us to revisit the masthead itself and streamline it as well. Looking at the details of the activity bar is a customizable UI interface. It's now the primary navigational utility for Galaxy. As I said, all the resources can be accessed from there. It is also customizable in the sense that every user can hide, rearrange activities, and place them as they want. But they still have the opportunity to click on this More button down here and access the entire list of activities quickly. We have enhanced this list and refined the activities, and we will hear more of some of these activities, particularly with regard to workflows in the upcoming talks during this session by Ahmed and Alireza in particular. And this extension of the activity bar and this refinement allowed us to, as I said, revisit the masthead. And we streamlined it and rewritten it as a much simpler, much more standardized view component without having the need of any configuration anymore. And we removed all the redundancies. So I believe that the UI should be very consistent and there shouldn't be any redundancies. It is, in certain exceptions, okay to have one UI element leading to two UI elements leading to the same feature. But for the main menu items, this shouldn't be the case. So rewriting this, we rely less on the drop-downs, less on labels, but more on icons. Additionally, the username is permanently shown now, and the details of your code are visible as well. Overall, this layout concept is that we start on the left side and move towards our data. So we, in this case, shown how a visualization activity is selected. A panel opens and you select the visualization you would like to use. Then you select a data set and the visualization is either rendered in the center panel or in the window manager. But generally the concept of using Galaxy with the data, of course, still in the history, is to move from left to right. And another major improvement and modernization we completed this year, and which was also a prerequisite for the overall user interface, is that we streamlined our grids. So the grids are the main resource management interface. We have about 24 grids in Galaxy, and what we achieved is that they all look consistent, behave the same, and we adopted this tab layout between the different resource access categories, so private, published, or archived in the case of the histories here. Overall, the benefits for the users are that it's a consistent look and feel across all grids. We have advanced filtering for all grids. We have sorting. and changes and improvements to grids will apply to all grids at the same time. So we don't have to revisit the individual items anymore. For developers, it has also some major benefits, that it's much more consistent with regard to how the API is accessed. So this was a driver to kind of modify or revise certain API endpoints
long
so
reads
that they, across
sequence.
different resources, behave in a consistent manner. Also, we got rid of a lot of legacy grid controller code and macros, so it's much easier to add or modify new grids and grid columns. We look a little bit on the technical side, how this was implemented. So basically, for every resource in the database on the right-hand side, a resource like users, histories, and pages, we have a UI-independent grid configuration. And this grid configuration specifies where the data comes from and what type of operations are possible on this resource. And then this generic or UI-independent grid configuration is consumed by the grid list component, which renders the grid and then facilitates the interaction with the API. So sorts it, requests the data, requests filtering, and operates on the data through a unified interface. We also modernized other components throughout this year. Here's the uploader. It's fully viewfied now. So under the hood, the entire code changed with regard to the modernization. And we know that this will now enable us to make actual changes, improve it, or enhance it because it is in this modernized framework. The same is true for the form modernization. We completely viewfied it finally. All UI elements are in view. And we also improved some of them significantly. I would like to particularly highlight the multiple entry selector, which Leila added. It's not shown in this screencast, but it's a very significant improvement to how one can select multiple entries. And looking at the overall progress, I think we are well on track on removing all the remaining legacy parts, but we still have some work to do. Meanwhile, though, while the UI team removes the last remaining outdated rendering technologies, we also in parallel make significant progress modernizing towards Vue 3. We add new tests, so this is a continuous process. And there are many topics which are important. I kind of picked two here, which I believe would be very useful in general for the overall UI. One is we have to modernize the data libraries and the data dialogues. They are not entirely streamlined yet. We heard a lot from John and also from David's work. We'll hear about how remote file resources have been extended and improved. And we have some legacy with the data libraries, the data dialogues. They don't work exactly perfectly well together yet. So there is a lot of potential for improvement, I think, streamlining this and bringing these features, which were developed in the back end, much more in a much more intuitive fashion to the front end. Another major project for the overall interface are visualizations. So we still have some outdated frameworks there. We need to make plans for the next year and implement them to have a much more capable visualization framework because that technology is still slightly outdated. And with that, I would like to thank everybody. This is the result of our work together throughout the year. It's always a great pleasure to be here, and I hope we'll continue to have a great conference. Thank you.
Hi, this is Michael from Elixir Hub. So thank you for the presentation. I think this was very nice to see the improvements. I'm wondering, and this might be a little bit beyond scope, to what extent have you thought about an interface that for languages that don't use the Latin alphabet. That's one. And then the other is a layout that is, for languages that are not from left to right, because the layout is very much anchored in that style of, yeah, looking at the interface. So I'm sorry, this might be beyond scope, but yeah.
I think it's an excellent question. It's maybe a little bit out of scope for me, but I know that there are some experts on this to have more experience probably regarding this topic. I think, I mean, we do have a language layout for localization. So there are definitely, and most of the code has always, so we see it in English, but you can switch languages. So as long as you have a translation mechanism, you technically can translate into any other language. So all the little text pieces on the UI in the code are tagged and they can be localized. So that's pretty throughout the code. It's pretty much everything basically. So you can switch through languages. The question here is how many languages, how consistent is it, right? So when it comes to the details, I'm not entirely sure, but I think we are 99% there, to be honest, to switch to different languages, as long as you have a mechanism to translate it. Because right now, I don't want to spend too much time on it, but so you have a text chunk and you localize it. If you change that text chunk and the dictionary doesn't match it right, then it won't translate it. So that's a problem. So I think there needs to be a better way to translate it instead of just having a static dictionary.
Yeah, sure question. Can you give us a bit more details about the plan for the data libraries? I see that you wanted to merge it with the remote file sources, but data libraries also has other features like permission roles that you can manage through them.
Yes, that's exactly the question. That's actually the question I asked John last night too, regarding these permissions. So apparently the remote file resources do support permissions, but not with the same granularity as the data libraries. We're thinking about different strategies. It would be actually, I have a question. Who here uses data libraries? Can you raise hands? Okay. Few people, but important people.
Both.
Okay.
Hello, everyone. I'm Ahmed, and I'm a part of the Shafts Lab team at the Johns Hopkins University. And the feature that I'll be presenting today is the graph view for workflow invocations. How to change the slides? Videos. I also have GIFs. Okay. So as most of us must be aware, workflows really are at the heart of Galaxy, and chaining the various number of tools available on every Galaxy server into workflows is really the best way to get the most out of Galaxy as a user. And therefore, we've done a lot of work in improving that part of the UI and improving the creation, editing, and sharing of workflows in general. And so this figure outlines just some of the features that have been added to the workflow editor, which is now not only easier to navigate, but also has seen a lot of features added to it. And also the code that goes behind bringing it to the user itself has also improved. So while running workflows is a pretty straightforward user experience, you use the powerful workflow editor to create or edit an existing workflow, and then click run, and then you get to the workflow run form. Or you can find an ideal workflow for your analysis through the modernized workflow lists that Alireza will be presenting after me. And just simply click run and then populate the data and run it. However, what happens after you run the workflow, that user experience is what we've improved with this new feature. And so the legacy interface for this looked something like this, where you would run a workflow and you would get a simple tab interface with initially a couple progress bars that would update in real time, yes, and they would show you how many jobs were scheduled, queued, ready, successful or failed. And then you would have another details section which you could drill down into and look at each step individually to find out where you are in your analysis. But even as I explained this, one can figure this wasn't a very intuitive experience. And so we need an improvement there. Now one can tell that a graphical representation here would really help. And since really the beginning of Galaxy, workflows have been stored and displayed in the really nice graphical interface, why not just use that same view to describe runs of your workflows? So therefore, that existing minimal interface has now been updated to a real-time graphical interface of your workflow run. So as soon as you click run, you see this graph view, which updates with every step and every job for each step, and you can see the progress in real time. So to summarize what this view looks like, you have the graph, which is the original structure that you made the workflow in or found it in. And instead, on each step, what you have is the job state count, as in how many jobs have what state. And so you can see that there. You can click on a step in the workflow to expand it on the right-hand side and then see what outputs came out of each step, and also the jobs that actually, for instance, if the job fails, you might want to investigate that. And so you click on the job, and then you can expand it below and find out what really went wrong there. You can obviously also keep track of multiple jobs on a step. Some of them have different states at a given point in time. So it really gives you a context of how much is done. And there's a screencast I don't think will play. Oh, it does. Nice. So this is what it would typically go like. You find a workflow, you run it with the data, and then you see this graph. And it really, it updates in real time. So you can follow it. It doesn't only work this way after the workflow is complete. So you click on the first step that was successful. You can see the output that came out of it. And yeah, you can eventually, if something gets, if a job fails at a given point in time, we'll see that here. Okay, so a job failed, and that's bad. And then so you click on the step, you can look at the data set. That might give you what you want. That might tell you, well, there was a string where there was supposed to be an integer. And then you can also obviously look at the job, and there could be a more complex standard error than this, for instance, and you could really tell what went wrong. So that's the idea. And so your workflow runs or the invocation doesn't just go away after you navigate away from the workflow run page. We've always had users have had access to their current running workflows or their prior workflows in the workflow list. And so obviously you would expand any workflow run in this list to see its details. And so we also updated this with the graph view for each workflow invocation. And so one use case for this could be that you have multiple runs of the same workflow. One of them failed, one of them passed, and you just want to see, maybe the inputs for one were appropriate and the others were not, so on. So that would be useful with this interface. That is not the only place you can find a list of your workflow runs. As Sam just presented with the activity bar, some activities have an associated side panel. And so if you click on workflow invocations, you would then see this list, this scrollable list of workflow runs in here. And same idea, it's an easy way to quickly switch between multiple workflow runs. And yeah, the idea with this. So for a start with this feature, like I said earlier, we have job state count on each step. But in the future, we could further build on this as we get user experience and user feedback on what can be improved. And maybe we could query more stuff from the backend and show it in here. And instead of just showing the job state count, maybe show the actual outputs on the graph and go from there. Another idea is, so for instance, the history panel, the current history, has for the longest time been the main area of context in Galaxy for users on knowing where they are in a workflow or in their jobs. And with this feature, it's an example of we now have another place for context. And so it would be cool to sort of build a bridge between the workflow invocation landscape and the history, the current history. And one of the ways to do that could be to add an invocation ID filter and bunch stuff in your current history for specific workflow runs. So that would be cool as well. And yeah, I'd like to thank obviously all the devs and everyone who worked especially everyone who worked on the workflow editor, because that for me was an example of how, since we've modernized our database and made it more and more reusable, it has become easier to add newer features as well. And yeah, thank you. Please feel free to stop by my poster for a live demo as well. Yeah. Questions? Okay.
Ask a hard question.
Yeah, go ahead.
Would it be possible, since not everyone uses it, to interpret like extract? show-
So essentially what you're saying is instead of just having the workflow run, we sort of have like this hierarchical structure of your history. That was the motivation behind this. But since with the history, I mean, you can have 1,000 data sets or collections in your history. That would be a huge query on the back end. And to show all of that within one graph, it would be pretty heavy on the server. But this was initially the idea because this is obviously a very cheap query from the back end. You just get the job state counts. But like I said, we could build on this and instead show you the outputs for a workflow. I know you said like, even if it wasn't a workflow in the first place, but in the same way, what we could do is maybe show parts of your history, query only specific parts that you would want. But yeah, we could build towards that as well. Absolutely.
Yeah, what about like select, click it, and it's just like it do it to build, like instead of extract, say, build graph.
I see what you mean. We do have a we do
People don't, especially
True. True.
or you built it.
Yeah.
And then if you could extract, do it, say, oh yeah, extract. That's
I see what you mean. Yeah, I think that's slightly different use case because what you're saying is, let's say you ran a bunch of tools that created data sets, and you're like extract the workflow. I mean, we already have that feature with the multi-select.
right. This is the
Yeah, but you could multi-select, and yes, that's one of the things we're also working on is improving that multi-select and adding more operations to it, not just deleting or hiding data sets, but actually extracting a workflow run from there could be a useful feature. Yeah. Yeah, we can work on that.
So-
Yeah, we could do that. Thank you.
Excellent talk and excellent feature. If we talk about simplified workflow run form, so as I understood you in your talk, right, this is all composable features.
Yes.
So can we maybe envision a workflow run form where you have on your left side your parameters of your workflow?
Yes.
You see on the right side the workflow as a, not as an invocation, but as a workflow. And then you click run, we turn actually the workflow into the invocation and then show the status. So even, I mean, really hiding the history at that point, really have just the workflow run form, parameters, and then the invocation where you see how the workflow is progressing. I mean, that would be the probably most easiest workflow run form that we have.
Yes, that's exactly what I was planning to work on after this, was sort of having, maybe even being able to drag and drop an item from the history onto a step, and that would be the input for that step. Totally, we could work on that as well. Yeah, that would be a very useful feature.
Hi, everyone. I'm Alireza from Galaxy of Freiburg. And today I'm going to use the enhanced workflow management in the Galaxy. So first of all, I will go through in the timeline for the workflow release that we had on Galaxy previously. And also we will see how features the previous one had and how many features the new one has. And also I will introduce and announce you what the future works that we are currently working on it. So everything all began on the previous GCC in Brisbane as we were discussing how we can improve the user interface and user experience on, especially on the workflows. And we also put all the information on the issue we have created. And we discussed our idea how we can improve the workflows, how we can add more features to the workflows, and how we can have something more responsive to the UI and so. as you know, the previous workflow release has many features, something like you could do search or tag management or bookmarking and running or sorting the common and useful features that every release expected to have. But it also has some limitations. It's especially based on the bootstrap table, which has some limitation on development and maintenance. And as a part of our effort to get rid of every third-party frameworks and to have more maintainable and more open source thingies, on Galaxy, we decided to not using bootstrap tables anymore. And also on the previous version, we had a different list to have the public workflows, our workflows, and shared workflows that was super complex to users to find their data. And so for many users, they didn't know either we have a public or the list of shared ones. So from the previous GCC, we start working on the new workflow list. And we now have this workflow list from the version 24. This is completely rewritten in view free. It's completely responsible in the UI, in the size of your screen. It doesn't matter which device you are using for working with workflows. It's completely responsive. And as you can see, we added more features and more buttons to the cards. We introduced this new UI, we call it cards and grids at the same time. As I'm going to show you some main features we have. So now we have the list and cards view. You can manually switch on them, or if you have a very small screen, it automatically turns to the small ones. Other important part is that you can now have everything in one page and just switch by using the tabs on the top. You can go through to see how many public workflows are available on the instance, or which workflows has been shared with you, from which user has been shared, or you can also filter on the users who has created that workflow. Other thing is that we introduced this quick view or preview of the workflows. It means that you don't need to open a workflow to see how many steps does it have, or how's the status of the share, or who is the author, or who has some description or so. You can just click on an eye to see the preview of the workflow in a blink of an eye. So, and about the responsive view, I think this is a part of our effort to move everything responsive and responsible to the UI sizes, to the device sizes. And right now, you can easily use your phone to view and manage your workflows right now. So now I want to announce this, our future work that we are currently working on it, to bring this list and card views in everywhere in Galaxy. It means that from, I hope we will have on the future release, this generic, responsible, and reusable component everywhere in Galaxy. It means that from now on, you will see this type of cards and grids everywhere. For example, this is the histories as a part of work in progress we are doing on it. It means that we, as Sam and Ahmed also said, we modernized the grid list, and we also will modernize them more to bring this UI to them. So it means that every components will have this main components. It means you will see the indicators, for example, is it shared or not? Who has created, where is the update time or create time? And also we'll see some useful badges like how many invocations, for example, a workflow had, or how many data sets each history has on top. And also you will see the tags in a consistent same place for everywhere in a list. So that was a really quick insight on how we did and how we work on this Galaxy. And I would like to thank UI UX working group as a for their support and help and for their feedback, and especially thanks for Laila and Sam for their support and being contribute to this thing. So that's it. Any questions?
good to see that the mobile phone support, or kids will be able to play with a workflow editor instead of game.
Sounds good. Thank you.
So, good morning, everyone. I'm very excited to give you some details about a pet project that I've been working on. Let's start first with a bit of context. I guess we can all agree on this sentence, more or less, since you are going this track. Workflows are essential for reproducible data science. However, publishing and maintaining high-quality workflows can be quite challenging sometimes, especially if you want to follow all best practices and properly annotate your workflows. So how does the Galaxy community tackle these challenges? So first, we have the EWC, which you probably already know by previous talks. For those unfamiliar, it's just a group of great people that help you designing and publishing your high-quality workflows, well-tested. And then in terms of tooling, Planimo is your best friend. I like to call it the Swiss Army knife of Galaxy because it's extremely versatile. I mean, there is practically nothing that you can do with Planimo. So why do we need this extension thing? Which, oh, actually, I forgot to mention that this project is a Visual Studio Code extension to actually work with workflow documents. So, well, because you can always have one friend, one more friend. Yeah, bad joke. Sounds better in my mind. The real motivation use case comes from a conversation with Wolfgang, which is one of these EWC members. And he suggested to create this extension to ease or address some of the pain points that he personally found when he was trying to maintain his own workflows in the EWC. And that brings us here. So I will quickly introduce some of the most interesting features of the extension. And of course, it's experimental, which is just a fancy word for saying that many things can or will not work as expected yet, but hopefully it will get better. Yeah, so the first most important thing is that it supports both Galaxy workflow document formats, the well-known .ga, which is JSON file. It's rather internal in the sense that it was not really designed to be edited by hand. It was meant to be ingested by the Galaxy workflow editor. And then there is the format 2, which is the next evolution of the format. It's a YAML document, and it's way more human-friendly. And the extension also supports test documents, which we will see shortly, some examples. So, right, one of the basic features of every language server is segmentation of hover. This is pretty useful for newcomers when they want to edit their workflow. You can just hover an element, and you will see the associated documentation with the element. Then there's the context-aware suggestions, which basically help you to edit or quickly edit your workflow document, making sure that you select the correct values and there's no typos to actually help you type faster. Then one of the most important features is the document validation, which is basically just like running Planimo lint at every change that you do to the document. So it actually also direct your attention to the exact element that may have an issue or warning. And then you can also select in the extension setting, you can select between two different options for validation. So we have the basic profile, which will just check that the actual workflow document is syntactically correct, and Galaxy probably will be able to process it. And then we have the EWC profile, which will check for almost every best practice that the EWC expects for your workflow. Hopefully all of them very soon. Then one of the most overlooked features is the outline. It can really help navigate huge workflows, which is usually the case for .ga files. And especially if you are not familiar with the workflow because you are reviewing someone else's workflow, it can really help you to find the interesting information that you want to check. Or yeah. So as I mentioned before, it also supports workflow test documents, which are documents that you use to actually create tests for your workflow. All the features are also supported there, and you can get completion or suggestions, validation, depending on the context of the workflow under test. And there's also a little helpful command that is only meant to be used .ga workflows, and it basically lets you clean compare two versions of the same workflow. So you may have noticed that when you make some changes of an existing workflow in the editor, you will get a lot of, let's say, cosmetic changes that the workflow editor, like position of node, things like that, that are not really related to the logic of the workflow. Well, with this command, you can actually temporarily remove all these elements and then use this clean version of the workflow to compare and actually see what you really change. And now the most exciting part of all of this is that you can just go to any GitHub repository containing Galaxy workflows and then press dot in your keyboard. Of course, the first time you probably will need to install the extension, but after that, you can enjoy the magic directly in your browser. And that's it. Thank you. There's no question. Oh, there. There's no question. Also, I mean, there will be during the poster session a demo, so you can ask whatever you like.
Thanks. Really excited about the code aspect of this. How much farther do you think you can go toward making this feel like excellent? My team hates writing Galaxy workflows, but I like writing excellent workflows. I'm wondering if you think there's room to get close to that level of composability workflow coding.
So, well, right now, this is really just for Galaxy workflow because it depends of the schemas. So all these features depends of the schema definition of the language, the workflow, let's say. So as long as you have one of these schemas that you can use to provide all these auto-completion values and documentation and everything, should be possible. But of course, it's a case by case. We really need to create something for it.
This is awesome. I was wondering if you're planning on a JetBrains version of this or PyCharm?
Not really. I mean, open to ideas.
I mean, I think that you should be way more enthusiastic. This is amazing work. And I think in response to the Nextflow comment, like, you know, we have a repository of tools that provide synthetic information for. I don't think they have any comparable. So I feel like Nextflow is a word that has kept a lot of people up late over the last couple of years. And I think this is the solution. And I think we're our savior. And I think it's going to be amazing if you can test it. Really great work. That's not a question.
Thank you.
Hey, so I will talk now about the Galaxy Codex with the idea of findings, tools, workflows, and trainings in one location. So I talk here in the behalf of everyone that contributed to the Galaxy Codex and everyone that will contribute to the Galaxy Codex in the near futures. So one of the problems that we got within the microgalaxy, but that comes to almost any community within, thematic community in Galaxy, is giving visibility to the resources that we have. So what we have. So we had the issue, we wanted to get everything we have available for microbial data analysis visible. So we wanted to know all the tools we have, all the workflows we have, all the trainings we have. The only thing is we started to do that a bit manually, and it's a bit cumbersome to do that and not easy to keep up to date. So we wanted to create a sort of catalog that can be easy to keep up to date and also to know how are these resources used over the different Galaxy servers. So that was the main things that started this project. So the first things we started is how we can extract tools. So what are the tools available within the Galaxy ecosystems? So you probably know that we have the toolshed. The only thing that we had issue with the toolshed is that toolshed expose all individual tools, all the wrappers. what we are interested is not really all the individual tools, but more the tool suites together in one locations. And it can be a bit hard to, at least when we started that, I don't know what is the status of the toolshed right now, but hard to query programmatically that we can keep up to date of what is available within the toolshed or what is available in the Galaxy ecosystem. So we took a slightly different approach. We took all the GitHub repository, collecting all the tools, so everything that is listed on the Planimo monitor. And then we query the GitHub repository to extract all the tool suites there. Then based on some filters, so we aggregated that. We query also the Bioconda to see if these tools available in Galaxy ecosystem is up to date to what is the latest version on the Bioconda. We also looked at Elixir bio.tools, which is a registry of tools to extract other metadata, for example, IDAM annotations, so operations and topics. So we aggregated that, we created a script for that, and then we could filter that based on some criteria, for example, the toolshed categories or something to get an idea of, hey, this is my tools for my community. So that was the first step that we did. And we added steps where we can manually create and make saying, okay, these are the tools we want to keep for our community. So that were the first steps. And another step that we did and we implemented monthly during the Elixir Biohackathon last year was to go beyond that. I mean, the structure is similar, but we added also the step of what is available and in which Galaxy servers you can find these tools. And also getting an idea, at least currently on Use Galaxy EU, the usage statistics of these tools. So how often these tools has been used over the last year. And then we improved a lot, also everything in times, and we have something running weekly to update this list of tools. We also created interactive tables. We have word clouds, for example, and we can then embed these interactive tools within any pages that for your community. So we have that for the micro galaxy, we have that for other communities. So that's what the idea. So the metadata, the Galaxy tool metadata extractor outputs export the data as a JSON CSV table. So if you want, very interesting, or online interactive and queryable table that looks like this. We know we need to really improve these tables. It's not the best. It's something dirty that we did quickly. So we need help on that. We definitely need. But these tables include metadata, IDAMs, the tools availability on Use Galaxy servers, and the usage on Use Galaxy EU. So a lot of information already. And then we also created materials to, okay, when you have these tables, how you create that to make that possible for your community, export the tools available for your community. So we have training materials to help you doing that and embed that table directly in your community page on the hub. So for your SIG, for example. So we did that for the microgalaxy community, and we figured out that we have more than 300 tool suites. So it's not tool individuals wrappers, it's tool suites there. So it can be much more tools there, individual tools. And then we started to try, we want to write a paper. So we need visualizations of what is available there. And when we started to plot that, we wanted to aggregate by IDAM terms. And we figured out that a lot of tools doesn't have IDAM terms associated because most of them are not linked to bio.tool registry from which were extracted the IDAM terms. So what we wanted to do is we organized an hackathon online in March where the aims was to really improve the annotations of resources, globally focusing on tools, but we also worked on tutorials to add IDAM's operation topics for every tutorials. And we have a tutorial, we created a tutorials to how to add and update best practices metadata for tools using the bio.tool registry. So we explain how to create the tools on bio.tools, how to link your tools to your Galaxy tools to bio.tools, how to add IDAM terms on bio.tools, etc., that we can get that better annotations. And over this hackathon, we managed to link 100 tools to bio.tools. We created 40 bio.tools, and we reviewed a lot of tools and their IDAM terms there. So it was a really, really successful hackathon if you also look at the stats that we extracted there. But okay, tool is great, but it's not only what we are for a community. So We moved from the Galaxy Tool metadata extractor and we renamed yesterday to Galaxy Codex. So the Galaxy Codex and the first step of the Codex is to also extract training. So we have a lot of trainings available on the Galaxy Training Network. You heard this morning, we have more than 400 tutorials. But maybe you want to just filter for your community, the ones that are interesting for your community. So what we do is we query, thanks to Elena and Saskia, we have a really great API for the GTN. So we use the API of the GTN to extract all the tutorials. And then we add IDAM operations from the tools because we have this information from the tool. We can propagate that to the tutorials. We also query the plausible API to get the visit stats. So how many times this tutorials has been visited and for how long. We also use the YouTube API to query to get the views of these tutorials if there is a videos associated to that tutorials and the feedback stats. And so we have one table, one results that show all the tutorials available with all this information, and then you can filter that for your community based on some criteria. And then we can propagate that, okay, these are the tools available in your tutorials. It needs to be also in your community tools, list of tools for your community. So we can also propagate that. So what now? So we have trainings, we have tools, we have trainings. What now? We want workflow. Sorry, I know I'm out of time. We want workflow. We want to create a packaging for community resources. So on-page templates, thing mentioning. Yeah, thanks. Link to Wendy, what she mentioned in the morning, having one page that unify everything. So we work with them with that for that. We want also to have deployment configuration files, so all the tools that you will need for your community to create a subdomains for all the tools available for your community that you filtered. We want to improve the best practices. So for example, in IUC recommendations, adding, okay, that would be great to have your tools also on bio.tools, that we can also improve annotations of the tools. Same for tutorials. When you create a tutorials, please put also your IDAM operation if you know that. That could be really helpful that we don't have to do that afterward. So that it's part of when you develop the tools. And integrate more communities. So currently we have the microgalaxy community, imaging community, and biodiversity. We will work with Wendy and the single cell during the Elixir Biocathon this year, but yours is more than welcome. You can also join. There is a training today with Paul on that. So if you are interested in getting your community within that project and within that codex, please join the trainings in the afternoon. And, okay, it doesn't display, but there are a nice background, sorry. Involving the whole community globally. So the community leads and community members to integrate your data there, giving feedbacks, what is needed, what you would like to see there, testing that. We will need helps from maybe some web developers to help us on the interface of that. That will be awesome. Anyone's in the community to really try to make the Galaxy Codex for the community by the communities also. And yeah, thank you.
Quick question. Just excuse my ignorance. Does EDAM cover non-life science?
It will. It's ongoing process, yes. But we also use, so we use the Elixir bio.tool registry, but we also link to, what is the name, BII, the bioimaging, BIII or whatever. It's another registry of tools for imaging. So we also connect to that. So we can connect to other registry if you know, or EDAM other ontology if you prefer to have other ontology. So currently we're focusing on that.
Hello, everyone. I'm going to run. I'm Giuseppe with Serena. We are here and we are presenting more an approach to development. I hope this will be of interest for both people who develop tools or people who support research group and developers. Mandatory company slide. So we work for a small company that supports research groups. We manage computing cluster, scientific computing cluster, monitoring, storage, and so on. and we are currently administering 2 instances of Galaxy. One is a production instance in a hospital that is used for diagnosis on real patient data. We all come from academia, so we know the struggles of research groups and so on. Personally, in my previous life, I was in Elixir, so I know a lot of you. Motivation. You know, there are different developers. They are at different stage in their careers. They come from different background. Maybe they are domain people and they want to automate something or create a tool. Maybe they are developers with computer science background. They have different constraints. Somebody just has their laptop. Somebody has access to HPC. And most of developers, in our experience, have more or less no knowledge on the administration part of this computing cluster. So they do not know what are the constraints, what they are going to face when they want to run their tool on a computing cluster. Or in our case, if someday they want to share their tool on Galaxy. So they built the tool with some target in mind and they want to move the tool to Galaxy. So what are DevOps techniques? These are techniques that may help in overcoming early overcoming obstacles that you may face while developing a software in general. First thing first, tests. That is something that usually is done later if done at all. And there are automation procedures like continuous integration and continuous delivery that are automated procedure that do something for you. If you followed yesterday Bioconda tutorial, everything that was explained there is using this kind of technology. So I made a list of the common pitfalls that we have seen when people try to develop a tool. The first thing, they want a shiny thing, and they want this to be good and easy to use, but user interfaces are a struggle if you want to run something on HPC or Galaxy. They usually have hard-coded file paths, so they know that their reference file is there, but is there on their laptop, is not there on the computing cluster. Also, like in all development, it's working on their machine, but their machine is messy. They installed different libraries, they tried different things, and eventually this software has to be moved somewhere else. And in the destination, you do not know if you have the same environment, or if you have the same constraints for memory and disk access and so on. So the solutions are to push for code modularity, so break the tool in different pieces, keep the user interface, the graphical user interface. It's good, but it should be a separate piece that connects to the main tool. Have parameters everywhere, so no paths that are coded in the tool, but everything is provided via command line parameter or a configuration file. I have a list of requirements and so on, and checks if when the tool starts, if there are available resources for what the tool wants to do. Test-driven development is key. The core idea is to have tests earlier. Before you write your code, you write the test, and you use all the technologies that help developing, like version control, having small commits, saving your changes early, and the automation in the platform that you may use for storing your code, like GitLab, GitHub, can run the test automatically. So if you wrote the test, the system is going to execute them for you once you perform your changes. And then you can add also the test with Planemo and so on, so you can have the full check from functional test to error test to is this tool is going to work on Galaxy, yes or no, in an automated way. Also, you can have different environments. Maybe you are not publishing your tool into the tool shed, but you are using the tool internally. There are machineries in the continuous delivery that help you package your tool, create containers, and ship the package and the container in private repositories. Or maybe you want to perform a pull request to the IUC tool repositories, and this can be done automatically. But it's required a bit of organization with using version numbers, tags, and so on. Done. If you have question besides now, we have a poster, and if you want to see an application of these techniques, there is a poster by Federica who works in the hospital, and they used these techniques to move an old tool to Galaxy by applying all these steps. Thanks.
Any questions?
So this has been the hurdle from the beginning, right? Scientists wanting to develop tools and environments and back, write something, share it, it's complicated, productionalize it. It's a big. How easy is this? Adoption.
It is easy when the goal is clear. So once the goal is not just I want to, you know, the old publication that says that after 2 years every software is not going to run and you cannot find it. But if they are really motivated to share their work, this is going to be easy because also they want to learn. And it's easy and it's easier for their life when they keep developing in that way and they do not struggle like before. So it's not that bad in our experience.
Okay, good morning, everybody. And enjoy the slide design of our PR department. This is a joint work with CESNET and Masaryk University. So this was my mandatory description company. Now, this is a long story on just 8 slides. So starting with the trivial one, probably all of you have sometimes heard about Galaxy. And to do the data analysis task in Galaxy, one needs some computing resources. This is integrated in Galaxy through the job runners that, that appeared for a long time, and there is a handful of them talking to different computing environments, typically batch systems. And those are specialized. Recently, there was the activity on development of Pulsar, which is an alternative way, which is universal and which wraps the interaction to those computing environments. And it's fine. It's mature. It's supported by community. It's stability around at many sites. It's supported by the European Science Gateway project and so on. But it's still a bit Galaxy-ish. So we have been looking about more open standards. And the one that was chosen was this task execution service defined by Global Alliance for Genomics and Health. And actually, I have seen quite many attempts to define the standard for accessing computing resources in my career. But this one is quite nice because it is just simple. It does not introduce too many corner cases, and you usually end up with simple definition of the task, or the components of the task have just 2 or 3 mandatory fields, and that's as anything nowadays, it defines a RESTful API with quite expected components and operations like submit the jobs, check the status of the jobs, list the list the task, and so on. The task definition itself contains input and output that are just URLs to access the files for both downloading and uploading. It can define some resources for computation, the size of memory, number of CPU cores, and so on. And the actual payload of the data analysis is defined as a sequence of executors, which are just containers. There is no other means to define the software. It must be a container, and there is a sequence of them and command associated to each of one to execute inside of the container. That's it. And to work on the data there are some volatile volumes that are defined in the task, and they exist there just for the execution of the task, and the standard guarantees that that all the volumes are mounted in all the containers in the same path, so that payload in the container. There are several implementations of the standard. Some have come from the European Elixir. There is Funnel that's from Oregon, and also Microsoft looks in this. So this is quite widely adopted already. So what you can do with it, you can either provide your implementation of this on top of your favorite batch system, or you can grab what we did. We just interface Pulsar with the test interface to leverage on older work that was done for Pulsar, but also expose standardized interface. This is the simple diagram how it looks in the Galaxy. What we did that we pointer. What we did, we grabbed some existing experimental test runner in Galaxy, and we extended and elaborated on it a bit more. This is still a universal component that if you provide an interface to another implementation of this, it runs, and we tested it at least with fun. Then we wrapped the Pulsar with the implementation of the test interface, which is quite lightweight component there. And its only task is transforming the definition of the job submission in the test standard to the command for the Pulsar interface that understands, and everything else is unchanged. It just goes down through the batch system. So it's executed on kernel. The tricky part is the access to the files. In our first naive implementation, we got quite many copies of the file. We start something, some decent input files that resides on probably some external storage that gets copied to the Galaxy server. Again, it is copied during the submission of the test job to the test storage. Then it's copied again to some site storage that is shared between the Pulsar and the workers. And finally, eventually, it gets copied to the local Scratch file system of the worker, and the analysis is done there. So too many file copies there, too much latency, too many possible bottlenecks. So what we did is just get rid of any copies that we could, and this is the result. That we, in our current implementation, we defer the copy of the file up to the execution of the job and the worker, and it's copied directly from Galaxy. And we are considering to integrate also with the deferred file access in Galaxy to go just directly to the primary storage of the file and avoid even the copying to the Galaxy if it is not necessary. It looks quite simple and quite straightforward. The implementation is not so straightforward. The devil is obviously in detail. What we did actually that we extended the test runner to generate the input-output files for the URLs for the input-output files and prepare a compose job for the test execution. Then there comes the test P component, which just translates the test job description to something that Pulsar understands, and prepares the job script, which also contains the URLs for arguments for the staging and stage out phases on the worker node, and the worker node itself executes the job script that was created here, and it contains 3 stages: the staging of the data, run in one container that usually contains just curl or S3 client or whatever. Then there is the payload container, which is unchanged, some biocontainers and so on. And stager container is again with curl that just uploads the data back to the server. Currently, we support both Singularity and Docker. This is configurable. So the summary: we followed the proposed open standard. We managed to integrate it on top of the Pulsar and connect it to Galaxy, so it works in the whole downstream. And we put some emphasis on the performance of the file transfer to avoid unnecessary bottlenecks and complication there. This is no rocket science, as I said. The schemes is quite simple and quite obvious, quite straightforward. The implementation had to deal with some details, and we just did it. We got a pilot deployment in one of our Galaxy instances that is going to production soon, and I will come to for further discussions at the poster that we this afternoon. That's it.
Hi, thanks. Thanks for the talk. Very interesting. Have you thought about integrating the TestP, the Pulsar repository, so that every time you install a Pulsar node, you also automatically have the test endpoint available for use? So to integrate the TestP, it's like a plugin on top of Pulsar, right? If I get it right?
Yes.
Have you thought about integrating it, the Pulsar repository on GitHub? Merge those two together?
Yes, it can be done. We are still waiting for some more feedback from the real production deployment to do so. Yes, but this is
Sorry, I wasn't here in the beginning, but question, how does it communicate? Does it also use RabbitMQ? Does it?
The test is defined in exposing the REST API. So in this setup, we just rely on this, that the computing interface exposes the port that you talk to it. This is authenticated. This is obviously not entirely open. And the Pulsar inside does not expose any interface from the machine. So the TestP internally talks to the Pulsar with the HTTP interface as well. It does not use the RabbitMQ, but that's opening the port for the test. It's the design of the standard. So we didn't try to cross this with the RabbitMQ communication with Galaxy.
What about without Pulsar, like running against AWS batch? Add a test APIs on top of batch.
Yes. Pick up.
Is this better? Yeah. So in the tests on top of Pulsar, I can see that that this would allow other systems.
Yes, exactly. Actually, good point from the very pragmatic view for just the Galaxy community. There is no direct added value. The added value here is in the integration of the open standard and opening the environment to interconnect actually in both directions. That we can with the development on the test job runner, we can eventually leverage on other implementations of the test and vice versa. That activities like the WES is workflow execution service, which uses the test interface internally to submit the workflow element, can go to POSA.
I'm going to tell a story about how we've hopefully improved the scheduling of jobs on Galaxy Australia to destinations near and far. So this is Galaxy Australia's deployment at the moment. It's concentrated in the southeastern corner. Our head node is in Sydney, and we have our main pulsar runners in Brisbane and in Melbourne. So if we zoom in on the southeastern corner, we have a local Slurm cluster in Sydney, which has about 200 CPUs and 700 gigs of RAM. And in Brisbane, we have a medium-sized pulsar cluster and 3 very large standalone pulsars. And in Melbourne, a large standalone pulsar and 2 small to medium pulsar clusters. So we have quite a lot of compute in Sydney and a lot more in Brisbane and Melbourne. So the local cluster can handle almost all job types. There's a limit to the size, and this is barring GPU jobs. It's the destination for almost all of Galaxy's built-in tools. Its availability is essential for being able to really do anything, run jobs, workflows, training, but it is prone to large queues, and that's a problem. Our remote pulsars can run bigger jobs. They can run a greater number of jobs. And they're a little bit further away in Brisbane and Melbourne, about 800 kilometers from Sydney. And transferring a lot of files between Sydney and Brisbane and Melbourne is becoming a problem. So we are scheduling jobs on Australia using the Total Perspective Vortex TPV job scheduler. I've drawn up a toy example with 3 tools and 3 destinations. The TPV maps jobs to compatible destinations based on configuration. And so this is often with scheduling tags. The 2 pulsar destinations require pulsar tag. So a tool will only go to one of those destinations if it has a pulsar tag. And we choose between destinations if there are multiple matching destinations. We look at prefer tags. If a tool prefers a destination, that's where it'll go. Following that, we look at the availability of CPU and memory at the destinations, which we determine from a database query at the time of ranking. So in this example, data fetch can only run on the local cluster. Snippy can run on any of the destinations. It will go to the one with the best availability. And Grappa prefers pulsar, so it will go to whichever pulsar destination has the best availability. In the past, we've just been trying to find enough tools that we can run on our pulsars. This is no longer the case. There are a lot of tools that will run on pulsar, and the pulsar network is growing, the job volume is increasing, and the file transfer traffic is increasing too. We need to consider the suitability of jobs for pulsar based on the resources used versus file transfer volume. And when we started running into this problem, we banned Fast QC and Trimmomatic from Pulsar because of their quick runtimes and fairly large file sizes. So what we want to do is reduce the I/O burden, but not at the expense of our precious local cluster. So we've developed a heuristic, the Pulsar score. It's similar to the Good for Pulsar GX admin query. We want high CPU time relative to the sum of input and output size. And we've adjusted this to account for RAM as well. So if a tool has, say, 1 CPU allocated and 60 gig of RAM, we consider that to be a high resource tool. We calculated scores from 30 days of job data and gave each job a score. The Pulsar score of a tool is a median value of the individual job scores. And so I've plotted this on a log scale because if I used a regular one, the smallest ones would be vanishingly small. There are some very high scoring tools like Muft. There are very low scoring tools like GFF Read. And if you look at some of the jobs, I can't believe we've been running them on Pulsar at all. And so we want to encourage the high scoring tools to go to Pulsar and perhaps avoid Pulsar for the low scoring tools. And so using these arbitrary cutoffs, we are sending jobs with tools with Pulsar scores above 10 to Pulsar. We're avoiding Pulsar for scores below 0.3. From looking at recent data, we've seen a 30% reduction in I/O to and from Pulsar and a 40% reduction in CPU time on the local cluster. And this looks almost too good to be true. So I've added some small print that this is a small sample size. We only had 1 week before and 1 week after to look at for this. And Galaxy is quiet at the moment because it's uni holidays. And the implementation is adding an extra config file to our TPV config. You can have as many files as you like. So we just have one that contains the Pulsar scores. We can automatically recalculate these to account for new tools and changes in resource allocations. And using rules, we just insert a prefer Pulsar tag for a job if the Pulsar score is above 10, and ditto for adding prefer local cluster if the Pulsar score is low. And in the future, I'd really like to collaborate more on the shared database. I think we have ways to go in container friendliness and Pulsar friendliness. We just don't really have much of that in the shared database at all. I would like to do something similar to this Pulsar score thing to find out which tools are likely to run for less than 6 hours so that we can plan maintenance on our VMs. We know when we can switch them off. And I have other plans to do with concurrency limits. And that's it.
Well, thank you very much. I guess obvious question, how universal is this? Can we use this in Europe as well?
Yes, you can.
Thanks. This is phenomenal work. And TPV really revolutionized scheduling for use Galaxy.org as well. And I think we have the same problem as you now with trying to make those same decisions about whether or not to send out calls. And so this is great work. Does that process of collecting the statistics to figure out the scores, does that take a long time to run and reintegrate, or is it something you do?
It doesn't take long at all, but there's a lot of made up numbers and decision making. I had to choose between mean and median, and both might have been good choices.
those numbers change?
Sorry?
Will the pulsar values change?
Yes, they will
Do
change.
you rerun them, or is there a recommended frequency yet? That out or thought about it?
I maybe every couple of weeks. I mean, if you allocate another 100 CPUs to BWA, its score will change.
talk. Thanks. Have you thought about making the pulsarness a continuous function? Like instead of deciding if you prefer pulsar in a binary way, make it more continuous or more probable to be scheduled on pulsar if the score is higher instead of yes or no?
Yes, I have thought about that.
Next iteration.
So Galaxy is a data-driven system with data coming in different forms, from reference data and configuration files to physical data. At the core of the system is Galaxy's data model, which defines the structure of the data, which facilitates Galaxy's business logic. The data model is defined as Python classes and consists of many entities and relationships or associations between them. The data representing the data model is stored in a relational database as tables and rows. The big Galaxy instances have tens of millions of such rows. In the very, very general sense, the data model has always been centered around the concepts of user, dataset, history, job, workflows, and of course the many associations between them. It started small. In 2006, we had 8 tables with 49 fields and 11 relationships. Over the following years, database objects were dropped, added, altered, and today we have 173 tables with 1,160 fields and 321 relationships among them. The point of this is that almost everything is connected. So it's really impossible to touch one part of the model without potentially affecting everything else. The scale of the interactions between Galaxy's business logic and the database is considerable. The data model is referenced from the code base in tens of thousands of different places, depending on what you count and how you count. The database is continuously read from and written to in a multi-threaded context every second that Galaxy is running. The data access architecture is the design of these interactions. And the things that we want from data access architectures are really facilitating data access in a reliable and performant way, ensuring data consistency, being flexible and supporting continuous change, well, while preserving sanity among the developers who have to touch it. While it is possible for Galaxy to talk to the database directly, it is impractical, and given our galactic scale, it's really infeasible. So instead, we rely on SQL Alchemy, which is a SQL toolkit and object relational mapper. It virtually handles all data access. SQL Alchemy is roughly the same age as Galaxy, and recently it has went through the greatest upgrade process in its history to 2.0. Migrating Galaxy to SQL Alchemy 2.0 has been a journey. So what has changed? A lot of things. Auto-commit mode has been removed. So in the past, transactions were handled implicitly by SQL Alchemy, which led to transaction logic, which was often very difficult to understand and very, very difficult to modify. Now it is all explicit. The ORM query has been replaced by CORS select object. So the query object took care of building SQL statements and executing SQL statements. Now, SQL statements are consistent across the library in doing one thing and doing it well, being SQL statements. Another example, there were many different ways a statement could have been executed against the database, and some of them bypassed an explicit database connection, which oftentimes led to surprising behavior. Not anymore. We don't have any more connectionless execution. Again, everything is very explicit. Overall, there are many examples of removed legacy patterns, simplified code. It all really boils down to a modern library, which is powerful, elegant, efficient, has a very strong emphasis on explicit, provides strong typing, and in all sorts of ways is a joy to work with. So again, migrating Galaxy. The process is complex. It's well documented. In part, it's inspired by the move from Python 2 to Python 3. The process is documented in issue 12,541. And in theory, it is simple. You start by dropping dependencies that don't support SQL 2.0, obviously. Then you enable warnings, which will raise a warning for syntax or usage patterns which are going to be removed under 2.0. Then you simply work your way through the warnings, one warning at a time. You pick a warning, you identify the root cause, you fix the warning, and you pick the next warning. Done. Then you enable SQL Alchemy 2.0, you fix any new errors, and you are done. In practice, we enabled the warnings, and we're hit by 485,000 warnings after running the Galaxy test suite. Yeah, they were mostly duplicates, but nevertheless, it was a daunting. Let's say we fixed the warning. Yay. Often there is no unit test for the data access. So so there is really no way of being sure that you fixed the warning correctly. But let's say we fixed the warning correctly. Well, how are we going to find all the other instances of this particular use case? Grep for a keyword. Everything is generic. You cannot grep for it. Can you grep for the usage pattern? Again, the usage pattern is very generic, so it's next to impossible to deterministically find all use cases in the code base. Many errors are very non-trivial. They require a rewrite of data access across Galaxy's code base. Removing auto commit took months to fix. Data access code is, of course, interleaved with business logic. It is spread across multiple methods and multiple files. I don't want to even go into the cognitive load, but it's completely untestable without major refactoring. And finally, data access code is everywhere, and it's all pre-2.0, low-level SQL Alchemy. A very long story short, it all started with, it involved refactoring Galaxy code towards testability. It was fundamentally, it was separating the business logic from the data access logic. And after that, we could test it. And for testing it, we had to write a new testing infrastructure for this particular testing, which creates a test database once per session. Then we use minimalist fixtures to set up very specific database state for every single test. You run the test, and after every single test, the database is wiped. It was lightning fast, so we were able to have as many tests as needed, and then we tested everything. And in the final steps, we literally kept track of errors on a weekly or daily basis. And finally, 24.1 runs on Galaxy SQL Alchemy 2.0. It is a team effort. Virtually everybody on the team, on the backend team, helped one way or another. Special thank you goes to Marius for handling some of the mind-boggling challenges involved in the session. And thank you also, John Chilton and David, for reviewing my horrible monster PRs. A few how-tos based on this journey, assorted tips on keeping data access code healthy. They're not a gold standard, but I know they will help the developers who have to touch this code in the future. So, separate statement building from statement execution. You can do it in a clever way on one line. But let's not do it on one line, because one, it is, even for simple statements, it is very difficult to maintain the right nesting of parentheses. Bugs will be created. Another reason is when you have it separate, then it is easy to identify duplicate logic, factor out that duplicate logic, and to helper methods and improve the code. Don't use query, use select. So query object replaced by select object. They're very similar, yet completely different. different and similar way in very subtle ways. So again, mistakes will be made, bugs will be introduced. So let's stick to select. Do not use identifier query for select statements. The identifier query is all over the Galaxy code base because we query object. It is very tempting to refactor the query object to the select object, but leave the identifier in place because it happens across multiple lines. Again, the objects are similar, completely different, subtle ways, bugs will be introduced, so let's rename it as well. Finally, there is still a ton of business logic and with data access logic, which be refactored. And this is how you do it. So let's say we have this monster method, and this is really a trivial method. Usually they are hundreds of lines long, with the red highlight highlighting data access code. So what you do is you refactor it so be all in one place, and then you can physically move it to a different location, passing it only the values which I needed to build the data access logic. Then from the same method, you call that new function, and this leads to much more readable code. Most important, now it is testable. Test it, and we'll be sure that it's correct. Finally, key points. Don't mix data access code with business logic code, please. Keep your data access code clean and simple, always. Try to keep data access code in one place, if possible. Reuse existing abstractions, and always write unit tests. Finally, SQL 2.0 makes things simple and really enjoyable, so contributions are welcome. Let's build together. Finally, lastly, two big projects involving the database coming next. One is the hard removal of items from the database because we claim space. Now that we have SQL Alchemy 2.0, we can move on with setting up cascading deletes in the data model. And the next step will be scripts handling deletion of data, including all the related data, which can be safely removed, very thoroughly tested. As an example, look at 18079, the PR showing this kind of process. Finally, Galactic Data Warehouse, with the key idea being separation of data in Run Galaxy from historical data. We have a project on during the CoFest, so please come talk to us, and thank you.
So, hello everyone, I'm Markus from 52 North, which is a not-for-profit company full of research software engineers. I mentioned that already yesterday, but just for those who were not there yesterday. And today I would like to talk a bit about a project we are involved in, which is the Open Science Persistent Demonstrator. And this project is run by OGC. OGC, just a few words about what OGC is. So it's the Open Geospatial Consortium. And it's quite a big initiative, also not for profit. There are quite a few members, quite a few communities involved. And they are very strong, they are very active when it comes to developing standards. So they adopted quite a few standards, but they are also releasing products and also data sets following their own standards. The challenge in this project, or for the OGC initiative in general, is that there are quite a few members who release a huge number of research outputs like source code, software, data sets, publications, and so on. And we are in a fortunate situation that these members want to use open science and fair principles. And what I can tell from my past is that this is not very common. So we are a bit in an open science bubble, I feel, from time to time. Not everyone would like to follow open science principles, but fortunately we do. We have some specific geospatial challenges. I'm not sure if they are very specific to the or exclusive to the geospatial domain. But yeah, there are some specific challenges which are, for example, very large and frequently updated data sets from very diverse data sets. So I think this is also a problem in other research domains. But we also have workflows that are that often use data and services distributed across multiple platforms. So we have several partners in this project, and they all have their own servers. They all host their own services. And one of the goals in this project is to connect these services. Just a little spoiler, so this should be done at the end using Galaxy. And we have applications across a very wide range of domains. So we are talking about the Earth system sciences, but also the domains within the Earth system sciences are very diverse. So the Open Science Persistent Demonstrator, the main goal is designing a platform to meet OGC community needs, and it's sponsored by NASA and ESA. And this is an overview of the key components of the infrastructure. So it's a distributed infrastructure. So one of these components is, or are the OGC standards. The other one is Galaxy, and we also would like to use the Open Science Framework, which is very similar to Zenodo. So we have the Galaxy Zenodo integration, and we would also need at some point something like that for Open Science Framework. And I will focus in the following on the standards and the Galaxy part. So one of the standards that I'm talking about is the OGC API family. And the OGC API is the set of standards developed by OGC for accessing geospatial data and services via the web, so via HTTP. One of these standards is the OGC API features, so you can request points, lines, polygons, stuff like that. Another one is OGC API records, which is in charge for metadata. And at the end, we also have OGC API processes, and they work very similar like Galaxy tools. So they take some input, they do some processing, and they provide some output. So the obvious question is, so how can we get these processes into Galaxy? And this is what I will talk about in the rest of this talk. So the nice thing is that everything is standardized. So we have a server running these processes, running these services, and all the endpoints are standardized. So for example, via /processes, we get all the processes that are running on a server. Via /process name, we get the process description of these processes. So all the input parameters, output parameters, and stuff like that. And via execution, yeah, we can execute these processes. Good, so far so good. But in the project, we have a few requirements that we need to meet. So the services should still run on the already existing infrastructure. So it's not an option for us to take the code of the processes and integrate these processes as tools in Galaxy. So because the partners want to have their infrastructure used, so we need to find another way to execute these processes remotely. The data transfer from and to Galaxy should be avoided ideally because sometimes the data is very large. So it doesn't make sense to send the input data to Galaxy, send the data to the first process, get the output of the process, send it back to Galaxy, send the data to the next process, and so on. So this would mean that we have quite a lot of data transfer, and this is what we would like to avoid. And there are some aspects that are already covered. So Galaxy should be used to configure the input parameters, and it should be able to connect these processes in a workflow. The first server that I looked at had 700 processes. So in the old way, we would create one tool per process. And this is, of course, not an option if we have 700 processes. So we need to find a different way. And one idea is to generate one XML file for Galaxy that includes all processes. It didn't work for the 700, by the way, because the XML file was like 20,000 lines, and this was a bit too much. So yeah, this is the old way. So we take the analysis scripts where we have the functions and deploy these functions as tools in Galaxy. But as I said, this is not an option. We have to make a little detour. So we deploy these functions as processes that are available via URL, and then write a wrapper that wraps all these processes. And at the end, we have one tool per server on Galaxy. And then it should be also possible to create workflows, and this is how it looks like. So we have a workflow that contains, for example, a simple Galaxy tool that is already there, but we have a wrap process from platform A, which is our second tool. And we have a wrap process B from the same platform A, which is also the second tool. So this is not a typo. This is not a typo because all the processes are in the same tool. So we don't have one process per tool, but they are all in the same. And this is how it looks like. So we have a little proof of concept. So at the top, you see select process. I'm not sure if it's readable from the back, but under select process, you can select all the processes that are included in the XML file and that are hosted in the process. And yeah, depending on what kind of process you selected, the UI inputs change accordingly. And we tested it. It was successful. We were also able to create a first workflow. So what you see here is an input data set that is the input for the first process that is hosted on a remote server, and this is connected to a second process, and this can be executed in Galaxy. It's also available in the shared workflows section on Galaxy, so if you want to try it out, feel free. It takes a few minutes to run, but under history, you will also find an example data set. So this should be, it should be possible to run it. All right, that is from my side. Thanks a lot for your attention.
Okay, thank you very much. So, as I was told, we have to leave this room and okay, one quick question, sorry. Björn.
Yes, exactly. This is something that I haven't described in this talk. So what we send to a URL is not the actual data, it's a link to the data. And what we get back from the process is also not the data, it's a link to the data. So we can just send the URL from one process to the next process and don't need to send the data around. The end result is also a link to the data, but you can just import it. So you can paste it via upload data. This is where you can paste it and download it. Yeah, I need to admit that I need to look at the third data set in more detail first.